Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello everyone, I'm John, a math teacher. Today, I'm with senior 6 students in our unit 4, integration. Here we are going to talk about basic integration formula. So remember, this is not the first lesson, right? We have been talking about basic integrals or standard integrals or basic integration formula. This was the part 1 of our lessons. Also, we had the part 2 for the same lesson. Means that we are going to continue with our lesson, right? But of course, before that, let us have an exercise. Thereafter, we shall continue with other basic integrals. Here you are. Please take your exercise book in your pen of course. Then work out these integrals. Number 1, you evaluate the integral of sec of 2x plus 1 tan 2x plus 1 dx. Number 2, integral of cosec of 3x plus 1 times cotan of 3x plus 1 dx. 3, integral of sec squared of 6x minus pi dx. 4, cosec squared of sine of 5x plus 1 dx. Then number 5, integral of x squared dx. I give you 1 minute to work out this activity. I hope you are about to finish. Not yet? Okay. Continue. You have a few seconds to end that activity. Okay, I hope you are done, isn't it? Okay, now let us find the solution or the answers for our activity. Number 1, you have integral of sec of 2x plus 1 tan of 2x plus 1 dx. When you see secant and tangent as a product, and the expression in the bracket is the same, immediately the answer is, this is the derivative of secant of x. So it means that the solution for this is secant of 2x plus 1, then plus c. We are done, right? Number 2, you see we have cosec and cotan. The expression in the bracket is the same. So it means that the integral of cosec of 3x plus 1 times cotan of 3x plus 1 dx, this is equal to minus cosec of 3x plus 1, then plus c. Number 3, you have integral of sec squared of 6x minus pi dx. integral of sec squared of 6x minus pi dx. You know that this is the derivative of tan of 6x minus pi. Of course, we have to divide it by a. Means that this is equal to 1 over 6, because remember that integral of sec squared of ax plus b dx is equal to 1 over a, right? Tangent of ax plus b, then plus c. For me, a is the coefficient of x. Understand x as the variable of integration. Means that I'll be having 1 over 6 tangent of 6x minus pi plus c. Then number 4, the integral of cosec squared of 5x plus 1 dx is not different from what you have here, but we have to change the sign. So it means that integral of cosec squared of 5x plus 1 dx is equal to, if I change from this formula, I put cosec like that, I'll be having minus, right? And this will be cotan x. Means that for me, I need the value of a, and a is the coefficient of 5. Means that this is equal to neg 1 over 5, right? Cotan of 5x plus 1, then plus c. The last integral of x squared dx. This is the formula of integral of x power n dx, which is equal to x power n plus 1 divided by n plus 1, then plus c. Of course, n is different from negative 1. Are we together? So then, from here, n is 2. Means that this is equal to x power 2 plus 1 divided by 2 plus 1 plus c, which is equal to x cubed divided by 3 plus c. And I'm done. Check your answers if they are similar to these ones on top in chalkboard. Are they the same? You check first. Are they the same? Oh, very nice. If they are the same, thank you very much. Let us continue with our lessons. Of course, the unit is the same. Basic integration formula or standard integrals. Part 3, right? We start on this formula. You know that when you differentiate arc cotangent of x, you get minus 1 divided by 1 plus x squared. Means that if I integrate this function, I'll be having cotan inverse of x plus c, or arctan of x plus c. Isn't it? Then, for that, you know the integral of minus 1 of 1 plus x squared dx, this is equal to cotan inverse of x plus c, or simply arc cotangent of x then plus c. This is the same, right? Let me give you an example for that. Integral of minus 20 divided by x squared plus 1 dx. If you observe this integral, and what you have here, the denominator is the same. The difference is only this minus 20 and the minus 1. And this is a constant. So applying the properties of integrals, I'm free to say, to take minus 5, minus 20 because it is a constant, then integral of 1 of x squared plus 1 dx, which is no different from minus 20 integral of 1 over 1 plus x squared dx, because you know addition is commutative. So then, this is equal to minus, right, cotan inverse of x, then plus c. I hope it is clear. Okay, thank you. Now, we continue with the other formula. You know that when you differentiate arc secant of x, you may get 1, okay, sec inverse of x derivative is equal to 1 divided by x square root of x squared minus 1. This is known from senior 5, isn't it? All right. Means that if this is the derivative of this function, it means that the integral of 1 divided by x times square root of x squared minus 1 dx, this is equal to sec inverse of x plus c. Isn't it? It is what you have here. Or negative cosec inverse of x plus c. Because if you differentiate this function with this presence of negative sign, it will disappear and you get the same. Let me give you an example for that. Integral of 2 divided by 3x times square root of x squared minus 1 dx. So these integrands, you remember that when you have an integral of f of x dx, this is known as the integrand, right? So I can make a short modification so that I can have this formula. Means that there is a constant here. This can be written like 2 divided by 3 integral of 1 over x times square root of x squared minus 1 dx. So our formula is here, isn't it? And this is a constant. I'll be having 2 over 3 sec inverse of x, then plus c, and I'm done. I hope it is very easy. Let us move on the other formula. This is somewhat different from what we have here because these are integrals corresponding to inverse trigonometric functions. Then this is a linear function. Remember, when you have integral of x power n dx, this is equal to x power n plus 1 divided by n plus 1 plus c. Because here I can even put 1. There is no problem. In the case I have the integral of ax power n dx, a is a constant, I'll be having a, then integral of x power n dx, which is equal to a times x power n plus 1 divided by n plus 1, then plus c. In the case I have integral of a linear expression like 2x plus 1 power 5, for instance, dx, okay? This is, according to the formula there, you'll be having 1 over a, 2x plus 1 power n plus 1 plus c. Then for me, a is the coefficient of x, right? Means that I have a half, right? I forgot to divide it by n plus 1 here. then 2x plus 1 power 5 plus 1 divided by 5 plus 1, then plus c. Means that I have a half times 2x plus 1 power 6 divided by 6, then plus c. This is 2x plus 1 power 6 divided by 2 times 6 is 12, then plus c. Is that difficult? Sure, it is very simple. If, for example, I have another example, integral of 1 minus 7x power 3 dx. This is not different from our formula, isn't it? They are not different. The problem is to organize your integrand so that you recognize easily the value of a, the coefficient of the variable of integration. So I can organize my integral to have integral of minus 7x plus 1 power 3 dx. Applying the formula, this is 1 over a, it means 1 divided by negative 7, right? Then minus 7x plus 1 power 3 plus 1, this is 4, divided by 4, then plus c. And I get negative 1 over 7 times 4 is 28, minus 7x plus 1 power 4, then plus c. And I'm done for this basic integral, whether you have integral of a linear function power any real number, right? Even n can be a negative number. You just apply the formula, the answer is always correct. It's the same. We have the other formula, which is related to the derivative of ln function. Derivative of ln function. Remember that when you have ln of ax plus b, this is a linear function, right? Divided by a, the derivative of this function will give you 1 divided by ax plus b. Means that the integral of 1 over ax plus b dx is equal to 1 over a. 1 over a is still there, right? ln of absolute value of ax plus b plus c. Remember why we add these absolute values. It is because ln function is defined for positive numbers only. That's why we have to add this absolute value sign. In the case we recognize the expression is positive, you can remove the absolute value sign. Now, an example for that, integral of 1 over 3x plus 2, for instance, dx. This is a linear expression of the form ax plus b. Of course, if I compare this expression to this one, a will be equal to 3 and b equals 2. Are we together? Oh, very nice. Means that applying the formula 1 over a, ln of ax plus b plus c, means that for me a is equal to 3. I'll be having 1/3. ln of our linear expression is 3x plus 2, then plus c. And I'm done. Even if you want, you can prove this by differentiating this function. 1/3 ln of 3x plus 2 plus c, derivative of this. I want to prove that my answer. This is a constant. It is 1/3. Then derivative, when you have ln of u, derivative is equal to derivative of u divided by u, isn't it? For me, u is 3x plus 2. Means that I have 3x plus 2 derivative divided by 3x plus 2. Derivative of a constant is 0. I have 1/3. Derivative of 3x plus 2 is 3 divided by 3x plus 2. Then we simplify 3 and 3 to get 1/3x plus 2, which was done here, isn't it? So it means that if you want to verify if your integral is correct, you are free to take the final answer and you differentiate it, you will get the integrand there. I hope you have understood. Let me give you a simple activity to check whether you have understood, and if for any example, any exercise concerning basic integral, you can get the answer. So activity. Okay. Evaluate these integrals. 1 integral of 2 of square root of 1 minus x squared dx. 2 integral of 3 divided by 1 plus y squared dy. Number 3, integral of negative 4 divided by 1 plus z squared dz. And 4, integral of 16 divided by 9x square root of x squared minus 1 dx. I give you 1 minute to evaluate those integrals, right? You know, people think that the variable is always the x or y, isn't it? So it is the only one. Even here, y, of course, is the variable. Z is the variable. The variable here is x. You can even interchange, even putting t, whatever you want, isn't it? So when you work, you may know that the integral is to be performed with respect to the variable x. Here the variable is y, z, and so on. Are you done? Maybe let me give you a few seconds, and we find the answers on chalkboard. Continue to work, but hurry up. Okay, hope you are done. Let us make the answers on chalkboard. Number 1, you have integral of 2 over square root of 1 minus x squared dx. You have a constant that is 2 times integral of 1 of square root of 1 minus x squared dx. And this is a basic integral, means that I have a 2. This is sine inverse of x plus c. Or we take minus cosine inverse of x, the same, or neg 2 cos inverse of x, then plus c, the same. Number 2, you have integral 3 over 1 plus y squared dy. So this is 3, the constant, integral of 1 divided by 1 plus y squared dy. This is arctangent, means you have a 3, tan inverse of y, then plus c, or minus cotan inverse of y plus c. Then number 3 is the same. You'll be having neg 4, 1 over 1 plus z squared dz, which is equal to minus 4, right? Tan inverse of z plus c, or simply 4 cotan inverse of z plus c. The last is very simple. 16 over 9 is a constant. So you get 16 over 9 integral of 1 over x times square root of x squared minus 1 dx, which is equal to 16 over 9 arc sec of x plus c, or sec inverse of x plus c, and I'm done. I hope your answers are not different from these ones, isn't it? I can't leave you without a homework. Okay, here you are. This homework is somehow a summary of our 3 lessons on this Unit 4 of basic integration formula. Please try to use those formula to work out or to evaluate all these integrals. Number 1, the integral of minus 5 divided by square root of 1 minus x squared dx. Number 2, integral of 12 over 1 plus x squared dx. Number 3, integral of minus 2 divided by x squared plus 1 dx. Number 4, integral of 3 divided by 5x times square root of x squared minus 1 dx. 5, integral of 2x plus 3 raised to the power 5 dx. 6, integral of x power negative 9 dx. 7, integral of square root of x dx. This square root of x can be written as x power half. And you apply the formula, right? 8, integral of x power 5 minus 1 over x squared dx. Then 9, integral of e power 4x plus 1 dx. The last, the integral of 2 power 3x minus 7 dx. Take your time to evaluate those integrals. I hope to meet you next time, right? Stay doing mathematics. I wish you all the best. Bye-bye.